This is the second problem 3 from practice quiz 11, and it says the table below provides an observation of 5 children with their parents. A researcher counted the number of times in a day the child was hugged. Calculate the relationship between age of child and the number of times the child is hugged. Write out the statistical notation using an alpha level 0.05 with 1 tell. Describe the relationship in words. So here we have each child, and for each child the researcher measured their age. So for example, child 1 is 3 years old, and for each child during the day the researcher measured how many times they were hugged by their parents. So here on this row, so that first child who's 3 was hugged 12 times in a day. And so what the problem wants us to do is to calculate the relationship between these two variables. And when you see to calculate the relationship, it means calculate the correlation. Additionally, it wants us to write a statistical notation and then to describe the relationship in words. So what we're going to do then is first calculate R. Then we're going to look for the minimum R to see if it's significant or not, if it meets that threshold. And then finally the notation. So we have 3 things to go through here. So the first thing we're going to do here is find our SP, SSX, and SSY to be able to plug it into my R equation. So as I go down this column, I should be able to add all those and then divide by 5, and that would give me my MX. So my MX should come out to 4. So the average age of these 5 kids is 4. Then what I'm going to do is go down my hugs column and come up with MY. And MY, when I add the 5 numbers there and divide them by 5, I should come up with 9. The next thing I'm going to do is create an X minus MX column. And right now I'm treating my age as X. So essentially I'm doing minus 4 to all of these. And as I go down that list, I have -1, 2, -1, 1, and -1. I'm going to do the same thing for my Y. So I'm going to do Y minus MY. And I'm doing, for example, 12 minus 9. So I have 3, 5, I'm sorry, -2, 0, -2, 1. The next thing I'm going to do is come up with my products, and I'll just leave it as P for my products, and I'm multiplying across each of these numbers. So I am left with -3, -4, 0, -2, and -1. And finally, I add these together, and I come up with -10. So -10 then is my SP. I then do, for my SSX, I'll take these here and square them, and I'm going to place them down here. So these are my squares. So I'm squaring each of those numbers here, 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 and here. So I have 1, 2, 1, 1, 1, and I am left, sorry, this one over here should be 4, I apologize. 1, 4, 1, 1, 1, and I should be left with 8. And that is my SSX. And finally, I do the same thing for the Y's here, move them over here, and I'm squaring each of these. And so I have 9, 4, 0, 4, 1. Add those together, and I have 18 as my SSY. So now I'm ready to plug it in here into my R equation, and I'm going to erase some stuff here to give me some space. So this is my equation down here. I have R equals SP divided by the square root of SSX. And then I'm going to replace SP with 10, negative 10, SSX with 8, and SSY with 18. And so those are my numbers being replaced. And so now I have 8 times 18, and that is 144. I then take the square root of 144, and I am left with 12. I then do negative 10 divided by 12, and I am left with negative 0.83. And so my R, my correlation is negative 0.83. So the next thing I'm going to do is find the minimum R required. To do that, I need to know 3 things. I need to know the number of tails, and here I said to use 1 tail. I also need to know the alpha level, which is 0.05, and then I need to know my DF. And DF equals n minus 2 for this case. Our n is 5 kids, so I'm going to say 5 minus 2, and that comes out to 3. So my DF is 3. So using those 3 pieces of information, I should be able to find out what my minimum R is. And in this case, my minimum R is 0.805. So I'm going to go ahead and create my visual. I have a barrier here where the barrier is 0.805. Anything above it is significant. Anything below it is not significant. And I'm going to compare or find where this number lies. Now I have a negative number. Therefore, I'm going to just take the absolute value, which comes out to, we drop the negative sign and we're just looking for 0.83. That's the number we're looking for. That number is slightly above here. So then this R is in fact significant. So the last thing I'm going to do is write my notation. R equals, and I had negative 0.83, n equals 5 kids. We found this to be significant, therefore P is less than my alpha of 0.05, and at the last thing I write is 1 tail. Here I'll just use 2 lines. And that is my notation. The next part of this question asks, now predict how many hugs per day you are likely to receive from your parents at the age of 1. So here it's asking us to predict, so we know we're going to have to use our regression equation, which is y hat equals b times x plus a. And so what I did here is I brought again our mx and our my and our sp, ssx, ssy that we had previously calculated. The first thing we can calculate is b, which is sp over ssx. And so I have negative 10 divided by 8 comes out to negative 1.25. So that's my b. My a equation is my minus bmx. And I have here 9 minus negative 1.25 times 4. I then have 9 minus negative 5. I have 9 minus negative 5, which technically is 9 plus 5. And that comes out to 14. So that is my A, that is my B. And so I've put my equation here, y hat equals B, which is negative 1.25, x plus 14. What I'm now going to do is substitute the age of 1, which is x, since my age is x. And I am substituting now here negative 1.25 times 1, my x, plus 14. Essentially what I'm left with is negative 0.25 plus 14, and that comes out to 12.75 hugs per day, which in reality we would say are 13 hugs in a day. So a 1-year-old likely to get 13 hugs in a day.